Am I pronouncing your name right, Austin? Okay. So this is your first class, right, Austin? I think your voice isn't audible.
Yes, ma'am, it's the first class.
Okay, okay. See, so you have missed a topic that is electric force topic you have missed. Electric charge and electric force. These two topics you have missed. So electric force has coulombs that you can take the video lectures. Do take the video lectures of these topics. Now, see, in today's class, so Tharif has also joined. Or again, class, the same thing. I have to leave in between today for again 10 to 15 minutes, as you all know, Ramzan is going on. So I'll start with the class, then we can. And yes, in the last class, I think they had given you the wrong assignment, no? Superposition principle assignment was provided. So in today's, we'll properly start with superposition principle, because without the knowledge of electric field, we could not start with superposition principle. Because superposition principle, this is not different for force, not different for electric field. Basically, superposition principle says what? See, superposition principle says that if you have not a single charge, if you have so many charges present with you, right? First charge is there, second charge is there, third charge is there. Austin, it may have that you will be having certain difficulties in understanding any topic because of missed past classes. So please have patience, understand whatever you're not able to understand, ask me, I'll explain you. And go through the video lectures, two to 3 or 4 videos I think will be there. So at least last 3 videos I'll suggest you should see. At least 2 or 3 you should see those videos, because electric field is also done. Electric force, electric field, and electric charge, these topics are done. All right, so then you can relate. But otherwise also attend today's class. Wherever you're not able to understand, let me know. All right, so superposition principle says what? If I give you 2 charges and I ask you to calculate the electric force, will you be able to do? You'll be able to do. You have told me also so many times how to find out the electric field. Now, how will you calculate? K Q1 Q2 divided by R square using your Coulomb's law, right? Now, if I give you one single charge and I ask you to calculate that electric field, will you be able to do or not? In the last class only we had completed the entire electric field topic. Electric field due to point charge also we had seen. Electric field due to point charge is what? KQ by R square. Please remember all the formulas simultaneously. KQ by R square. But if I say I have Q1 charge here, Q2 charge here, and let's say so many charges I have, n number of charges are present, nth number of charges, and I have given you this point P point. I've given you this point P point for calculation. And now I'm asking you, tell me the electric field at this particular point. P point is there. Tell me the electric field at this particular point. So how will you calculate? Will you tell me electric field due to first charge or second charge or third or nth, whichever number is given? No, of course, you have to include all the electric charges. So what to do? Firstly, you will find the electric field, let's say, due to this charge. This is electric field is always away for the positive charges. So this will be the direction of it. Same thing. This is the second charge. This will be the direction E2. And similar way, whatever n number of charges are there for third, same thing. For fourth, same thing. For fifth, same thing. Likewise for nth, this will be electric field due to nth. Now what will you do? For the net electric field, you will calculate the sum of all these electric fields up to En. Now this means what? If first is coming 1, second is coming 2, so should I add it like 1 plus 2 and give you 3 electric field? No. Which type of quantity is electric field? Electric field is a vector quantity. So if you have 3 electric fields at a point, 4 electric fields at a point, 2 electric fields at a point, you cannot directly add it algebraically. You have to vectorically add it. When I write the arrow above E, that means that electric field is in its vector form. So net electric field is E1 plus E2 plus E3 plus E4, but in vector form. For example, if E1 and E2, let's say they are making an angle of 60 degree. So you will use proper parallelogram law, under root E1 square plus E2 square plus E1 E2 cos 60 degree, like this. You will not say E1 plus E2 directly the way we calculate in algebra. No. Fine. You cannot do it in that manner. This is what is the superposition principle. Had there been forces in place of electric field, we would have done the same thing. I have to leave class. I'll join you in 10-15 minutes. Till the time, note it down. I'll come and I want to discuss questions based on superposition principle. Here it's a Maghrib time over here, so I have to offer the namaz also, and I have to open up my fast also. Please bear with this class. For Ramzan, at least we have to have this. All right, so please note it down. I'm just coming. Yes, class. See, so yes, I was discussing with you, those who have joined late. We were just discussing that, see, if more than a single charge is present, for example, Q1, Q2, Q3, Q4, up till Qn, these many charges are present. So how will you calculate the resultant? Right. So you use a principle that is known as superposition principle. This is not a law. This is just a principle which is valid for electric forces also. It is valid for all the vector quantities. It's simple vector law, no? When you have vector quantities, you'll add all the quantities vectorically. If the quantities are scalar, then you'll add all the quantities algebraically. Simple basic law is this. This is what is meant by superposition principle. So the statement also of superposition principle, this says that for a system having n interacting point charges, net electric field at a point is the vector sum of field due to individual charges. This can be electric field also, this can be electric force also. Now in this you have to have a concept of neutral point. We'll see question right now, only we'll see a question where you have to have in the knowledge of neutral point. What is meant by so what is meant by neutral point? See, this is a point where net electric field or net electric force, all these cancel out each other. So this is a point where, for example, let's say in this line, this is a point, neutral point. Let's say this is a neutral point. So here what will happen? All the electric forces that are occurring towards the right side will be equal to all the electric forces acting along the left side. Then only what will happen? Net electric field will be zero. This can be clear from this example. You can write down these things later. First, understand this question. This says that two charges plus E and plus 4E, they are placed at a separation A. Let me draw it simultaneously. This is plus E. This is plus 4E. I'm marking this point as A. I'm marking this point as B. With a separation A between them. So it means the net separation between these two charges, this is A. At what point on the line joining the two charges net field is zero? So this is exactly what is meant by neutral point. When it says no, a point where net electric field, net electric force, any of these quantities, if it mentions you, is zero, this means it is talking about the neutral point. So this means that this is the neutral point. So what is the separation? Now you can tell the separation from either of the charges. See, let's assume we do not know where is the neutral point, and these are also not symmetrical. Like you cannot mark it exactly at the middle point. Where should the neutral point be lying? Let's say, suppose this point I am saying N. This is neutral point. Some random point I have taken. Fine, this is some random point. Let me take this separation from plus E to N as X. Class, tell me one thing. If this separation is X, entire AB was A, how much will be Bn? How much is left now?
A minus X.
A minus X, right? So how much is left? This is A minus X. So now electric field, when it says no electric field, what we'll do, see, electric field, because of this plus 4E at this particular point, it will move away. This will be electric field due to B point moving away. And when we say electric field due to this A point, that is plus E, that is also positive. So electric field will be moving away from A. You can see by the figure also that net electric field is zero. Now what is meant by neutral point? This means that EA vector plus EB vector, their sum is zero. This means no, their sum is equal to zero. That is net field is zero at neutral point. Net field is 0 at neutral point. Now see, if both the fields are 0, this means you can easily equate these as AB, EA equal to AB directly. Now, what did I tell you? What is the magnitude of electric field? How do you write the magnitude of electric field for a single charge? General formula is K. That is the constant, dielectric constant, which we write Q, the charge that is given to you. So K, Q divided by square of separation between them. What was Coulomb's law? Coulomb's law was K, Q1, Q2 by R square. This is K, Q by R square. This is the general formula for it. Put it for EA, that is this charge. If we put, this will be K. What is the charge at A point? E. So E. What is the separation of charge A from this? We are calculating at this neutral point, no? So we'll see the separation from neutral point only. So separation of charge E plus E, that is this charge, from N. This is how much? X. So how do we write? KQ by R square. So this will become KE by X square. This part equal to EB. Now someone will tell. Yes, Humam, can you try? Can you give it a try for electric field at this B point? Just try, just place, keep it on this. So for electric field at neutral point because of this charge. So at least start with it. I'll help you. Humam?
KQ by A
Yes.
minus X.
Right. So what is Q here? Value of Q that we should put? What?
Plus 4 the charge only.
Perfect. Perfect. So K charge is 4E divided by separation from the neutral point is A minus X. So we'll square it. A minus X square. All right. Now see KE, they are getting cancelled. We can take the root of all these, right? It's better if we take the root of all these. Or you can do one thing, you can write K as 1 over 4 pi epsilon naught also, that will also work. So we are left with what? We are left with 1 by X square is equal to 4 by A minus X whole square. Take the root on all the side. This will become only X. This will become 2 divided by A minus X. So A minus X becomes 2X. From here we have A is equal to 3X. So X is equal to A by 3. X is equal to A by 3. Now see, depending on your question and exam, whichever question you get. For example, this X is coming out to be A by 3. This means what, class? That the neutral point is at a separation of A by 3 from plus E. And A minus A by 3 will become what? A minus X was no for the other part. And X we have A by 3 now. So this becomes 2A by 3. So it means it is at a separation of 2A by 3 from this plus 4E charge. Here we have our neutral point, which we were calculating. This is how we calculate neutral point, and this is how, if we have more than a single electric field, we manage. We'll see some more questions also. If this is clear, note it down from wherever you are having any difficulties. Any part you're getting stuck while writing, let me know. I'll clarify. Then and there, you can text me in the chat column also. I'll clarify whatever doubts you have. Note it down first. 2a by 3, see this way. One second, class. This entire was a, this part was x, this part was a minus x. So if x is coming out to be a by 3, so a minus x will be a minus a by 3. LCM is 3. 3a minus a is left, that is 2a by 3. So it means this part that is left is 2a by 3. Add 2a by 3 plus a by 3 will give you a back. That is the resultant AB. Now clear?
Yes.
No, see, when you write a minus x, no, this entire is a. This part we have taken randomly as x. You can take from any part x. Had you taken this as x, no, a minus x, your x would have been 2a by 3 because the value remains same. When you say x minus a, that means what? X is this small part. From this small part, how can you subtract this larger a? Right, so it has to be a minus x. From a, this means what? This means from this bigger a, smaller x has been subtracted. So whichever part is left is bn. Hey class, one more thing. Just to make your calculation work easier, if you have a symmetrical system, like in this question, this wasn't a symmetrical system. One charge was E, so other charge was plus 4E. If you have a symmetrical system means, for example, if I give you two charges, this is plus Q, this is also plus Q. This means this is a symmetrical system, right? Both the sides are equal. So in this case, if you are asked to calculate electric field at the center, not the neutral point, nothing else. At the center, if you are asked to calculate the electric field, let's say at the midline of this, at the center of this neutral point, let's say here will your neutral point will lie, because electric field at the center will be equal to 0. Fine. Now you increase the number of lines and increase the number of charge. For example, if we take triangle, so let's say this is plus Q, this is plus Q, this is plus Q. At the center of this, electric field will be 0. If I make this as plus 3Q, one of the charges, then your system won't be symmetrical. Right now, all the charges are equal and all the charges are balancing each other, right? So that's why net electric field or net force also, this is valid for electric force also. So electric force, electric field will be 0. Increase the number of lines. Let's say plus Q you have here. This is a rectangle, it's a symmetrical figure. At the center, if you are asked to calculate electric field, 0. Or you keep on increasing. Suppose, let's say you have a pentagon with you. So plus Q here, plus Q, plus Q here, plus Q, plus Q. So it's a symmetrical system. All the charges are equal. So in this case also, your electric field at the center, electric field and electric force, both the quantities will be 0. And that is calculated through vectorically only, but you don't need to do that. Fine, you just directly learn this. It will help in your calculation, and especially those who have to appear for entrances after class 12. This is a very important thing. And ultimately you get a center, you get a circle, right? At the end, you finally have a circle. So at the center of a circle also, if you calculate electric field, this will be 0. After this, hexagon will form, septagon, octagon, nanogon, and all those. These will keep on moving. Finally, n number of infinite lines will form a circle, and at the center also of a circle, electric field is 0. Note it down. At least two questions minimum. We should see good questions, one on force and one on electric field based on superposition principle. Before that, just don't note down this part, then we'll start with this question. Remember, your system has to be symmetrical. This is important. Now look here, class. We have to find out electric field because of all the charges at this point. So one by one we'll start. Let's name this something as A, B, C, D, so that when I'll refer, you will be able to mark it. So the charge present at point A, it is a positive charge. So electric field will move away from the charge. So at this point O, you are calculating. If I move this way, it will be towards the charge. So away should be, this is towards it. This is EA. I'll find out the magnitude. Let's write this first. Come to charge P, plus 2Q. Again, it's a positive charge. I should move towards or away. It would be away. So this is electric field due to B. Come to C charge. This is negative. So I should move towards the charge. For negative charges, we always take negative towards the charge. So if I move in this direction, this will be now away for C charge. So towards will be like this, pointing towards it. This is EC. And same way for minus Q pointing towards minus Q, this will be ED. This is what we have. Now we'll see the resultant later on how to see it. First, let us find out this magnitude of every electric field. At least all individual electric fields, we should find A, B, C, D, so that we have that in hand ready. Then we can place it, how to use superposition principle also you will see. See here. If this is A, right, this is A. We have to find out this part. So if you find, we have to find out OA. So firstly, we'll do what? We'll write OA equal to OB equal to OC equal to OD. But what is that value? We do not know. But we can do one thing. This triangle, in triangle, if you look in triangle ABC, what is AC? AC is actually equal to under root A square plus A square. Right, Pythagoras theorem, if you normal PT, Pythagoras theorem, if you'll apply. So what is AC? AC is 2A square under root, that is A root 2. So what will be OA? OA will be half of AC, that is A root 2 by 2. If you rationalize this, this will come out to be A square, A by root, not A squared. This will be A by root 2. So why did I calculate this OA? Because for electric field, we need to have none the separation of the charge from the point. So all the charges are at separation from O, but we do not know what is the magnitude of that separation. Now we know, now we can easily fit in the values of electric field. We know the value of electric field for a point charge is KQ by R square. Remember this class. We just have to fit everything into this formula. Fine, let us start with the first charge. Let's say if you talk about charge, or let's start with this B. Let's solve this side first. Let's solve this diagonal first. So this is having EB. Now what is EB equal to? Look in the figure. K Q. What is the charge at B? 2Q divided by R square. What is the separation of O and B? Just now we have calculated A by root 2. So R square. So you will square A by root 2. K Q by R square. K Q by R square. This is what we have written. So this will become root 2 into root 2 will become 2. And that 2 and 2 will get multiplied here. That will become 4. KQ by A square. Fine. Come to charge. Which is the other charge for this? D, right? EB and ED. This I'm just solving this now. So what is charge? This will be, ED will be C. This part is ED, no? K. What is the charge here at this D point? Q. So KQ by R square. Now R is separation of charge from the point of calculation. Separation of Q from O. That is A by root 2. This will also be A by root 2 whole square. So again, root 2 into root 2 is 2. So 2 will go up to KQ by A square. This is it. So what was this diagonal? This diagonal was EB and ED, two vectors in the same direction. How do you take out the resultant? You add it, both are in the same direction. So what will be the resultant of this arm? Directly ED plus EB, which is 4KQ by A square plus 2KQ by A square. That is simply 6KQ by A square. Have we got our answer? No. This is just resultant of this part. That is, instead of writing EB and ED, we can write now single E1. Let me write this as E1. What is E1? E1 is 6KQ by A square. But now solving EA and EC, this is still left. We haven't solved it. So let's write EA. Now see, same thing for EA will occur. EA is charge is Q. What is the separation of charge Q from center O? A by root 2. Are you people understanding this or not? K, Q will be small q because that is the charge on A, and separation from the center is A by root 2. So if we write EA, that will become K Q by, again, A by root 2's whole square, that is 2KQ by A square. Last is left, which is EC. Faiza, can you try this? EC. This is electric field at point O due to this charge, -2.
K2Q by
What is the separation OC?
A
O,
under root 2.
yes, A by under root 2. See, OA we have calculated here, and OA, OC, OD, OC, all these are diagonals of square, and they are equal. So separation from the center of C point will also be equal. So very good, Faiza. This will be, again, this will be K into, we'll not write -2Q. Very well, she eliminated the negative sign because we always consider the magnitude. So K into 2Q divided by, again, A by root 2. The separation is A by root 2 square only. So that becomes, again, this becomes 4KQ by A square. Now see, this arm was like this, EA plus EC. At least let us get our E2, final E2. How can we write our E2? So same thing, you can add EA plus EC, you will get 4KQ square plus A square plus 2KQ square by A square, which is equal to 6KQ by A square. This is also equal to 6KQ by A square. But now you cannot, now no more direct addition is possible. Do you see this? Now no more direct addition is possible because your one vector is like this, E1, 6KQ by A square, and another vector which we have just calculated, that is E2, is like this. And since this is a square, obviously all the sides are equal. This is a square. For a square, all the diagonals bisect, all the diagonals are perpendicular bisectors of each other. And also the entire angle is 360 degree. So if you take this, just this angle, no, for the calculation, this angle will be 90. Do you get this? The angle between one is by property of square. Property of square says diagonals are perpendicular bisectors of each other. Without even the property, you can say the entire angle is 360. That is getting divided by 4 parts. So each part will be 90 degree. Every angle is 90 degree. So now you have to apply your parallelogram law. It's like you have two vector quantities. You just have to solve it. You have these two, E1, E2, with an angle of 90 degree between them. So how do we write net electric field? You will use the proper parallelogram law formula. E1 square plus E2 square plus 2 E1 E2 cos 90 degrees. And what is cos 90 degree? Rabia. Yes, Rabia. What is cos 90 degree?
0.
0. Perfect. So if cos 90 degree is 0, this means this entire term will become 0. 2 into E1 into E2 into 0 will give you 0 only. So what are we left with? We are left with under root E1 square plus E2 square only. Now tell me one thing. Isn't the magnitude of E1 and E2 same coming in this question? 6kq by a square. So can't I say that E1 is equal to E2, which is, let's say, some E whose value is 6kq by a square, just for the calculation. So I can write this as 2e square under root, which I can write it as e into root 2. And what is the value of e? So resultant answer, e is 6kq by a square multiplied by this root 2. This is how you use superposition principle. This is how you solve answers. One more question we'll do, at least based on electric force we should do. We'll do question based on electric force. But first note down this question, understand this question. Based on this, we'll do one more question. This is how lengthy questions on superposition principle are asked. And see, this is nothing different we have used here. Right, everything this we were studying. Electric field due to point charge was also used. Vector laws you already knew. It's just that we combined it. That is what is meant by superposition principle. That's it. Note it down. See, in the parallelogram law, the law only says that a square plus b square plus 2ab cos theta. This is not sine theta. So a square plus b square plus 2ab cos theta is the parallelogram law, where a and b are two vectors and theta is the angle between them. That's why cos. All those who have completed the written portion, try this question first. I'll discuss this. Equilateral triangle is mentioned here. the class this says that charges of plus 5 microcoulomb, plus 10 microcoulomb, and minus 10. So let's say plus 10 microcoulomb minus 10 microcoulomb, and this is plus 5 microcoulomb. So equilateral triangle is there. This means this angle is 60 degrees. Determine the resultant force on charge A. Now center is not given. This is charge A at this particular point. So see, at this particular point, because of this, see, this will move away. This will be EB, right? This will move away from the charge. So not EB, sorry, electric field we are not calculating. No, we are calculating the electric force. So this is going to be F1. Same way, this is negative charge. We'll move towards the charge that is F2. So their resultant would be somewhere here. This is the resultant F. And what are these angle F1 and F2 making with each other? If this is 60 degree, this angle will be 120 degrees. Fine, it's like this is one force F1. This is second force F2. Their resultant, see, adjacent sides of parallelogram separated by angle 120 degree. It's very clear from here. Now see, you just have to find out the magnitude of the forces. Here you will apply simple Coulomb's law. Coulomb's law says that F1 will be K Q1 Q2 divided by R square. So see, what is K? 9 into 10 to the power 9. Q1, one charge is 10 microcoulomb, that is 10 into 10 to the power minus 6. And the other charge that is on A is 5 microcoulomb. That is 5 into 10 to the power minus 6. So K, Q, and what is the separation between them? It's an equilateral triangle. So all are separated by 5 into 10 to the power minus 2. That is 5 centimeter all. So F1 will be equal to 180 Newton. And its direction will be towards BA. That is, this direction is towards BA. This is the direction. This is towards BA. So only F1 we know till now. What about F2? F2 will be K, Q1, Q2 by R square again. K will be 9 into 10 to the power 9. Q1, one charge is 10 microcoulomb, again 10 to the power minus 6. Another charge is 5 microcoulomb, 5 into 10 to the power minus 6. Separation between them, 5 into 10 to the power minus 2 whole square. This will also come out to be 180 Newton. All right, but the direction is towards AC. This is towards AC. This is the direction. No, this is the direction towards AC. Now see. You just have to solve these vectors. So F net will be equal to under root. How do we write? A square. So 180 square. Or let's write it as F only. We know the magnitude. Let's write it as F only. So F square plus F square plus 2 F1 is also F. F2 is F cos 120 degrees. So this becomes 2F square plus this also becomes 2F square into what is cos 120 degrees minus half. So under root of this. 2 gets cancelled. Not from here. This 2 and this 2 gets cancelled. And what is left? Under root 2F square minus F square. That is root F square. Under root F square. Under root F square is equal to F only. So, and what is the value of F? That is 180 Newton only. So F net is also 180 Newtons. This is how we have to write it. This is also 180 Newtons. Yes, one more thing, class. If we have to find out the direction here. See. This is F1, 180 Newton. This is F2, 180 Newton. This was 120 degrees. Let's say this is some angle beta. So this vector becomes A, this vector becomes B. What is the value? How to write the direction? Tan beta is B sine theta by A plus B cos theta. This is how we write the direction of parallelogram law, right? After magnitude we calculate, magnitude of resultant we calculate by that under root square thing, and direction we find by this. Those who are not able to understand this, it means your basic vectors is weak. Please get your vectors clear. So this will be equal to 180 into sine 120. That is root 3 by 2. This will become root 3 by 2 divided by 180 plus b cos theta, 180 into minus half. So once you'll solve this, this comes out to be root 3. It means this beta is what? Beta is 60 degree. This means that beta is 60 degree. This is about the direction part, but the magnitude is from here. F net magnitude 180 Newton with respect to 60 degree from F2. This is how you have to write your complete answer. Note this, class. Note this and text me done once you have written. In the next class, we are going to start with dipole moment. Yes, class, all of you have completed or not?
Done, ma'am.
Done.
So yes, class, in the last class, question 1, 2, and 5 were given because superposition wasn't covered till that time. So for today's class, assignment questions will be question 3 and question 4. All right, these two questions, these were left. So now